team is back with another episode of Topical Explainers for the first chapter of CAIE AS Level Mathematics Pure 1. To simplify the topics and provide us with all the information needed, we have Pratyush with us here today.
Hi guys, my name is Pratyush, and I've just recently joined the ZNotes team, and I'm very excited to be bringing you AS Mathematics video content. Today we're going to be working on Pure Mathematics 1 Quadratics, which includes factorizing, completing the square, inequalities, simultaneous equations, the discriminant, simultaneous functions, and quadratic in a function of x. So let's get started. Deep dive into the subject. Before we begin this subject, you're going to need a few things. You should be familiar with algebraic manipulation, which is moving parts of an equation around. You should be familiar with factorizing quadratic equations already, just the simple stuff like opening brackets, difference of perfect squares. And you should know how to deal with exponents and roots, which is like squared and square roots. Are you familiar with all these, Vyomesh?
Yeah.
Yeah. So I think you've heard of a linear equation already. That's where the equation forms a straight line, such as here in y equals mx plus c form. And a quadratic equation, if you graph it out, it does not make a straight line. It makes a curve with one. It's like a arc of a throwing object, and it's written in the form ax squared plus bx plus c, and the general formula is that where a does not equal 0, because if a equals 0, then you'd basically get rid of a, and that would not be a quadratic equation. And it doesn't have anything higher than x squared, so the highest power is 2. The solutions to a quadratic equation are the values of x for which y equals 0, such as this curve where it's y equals x squared minus x minus 2. And that's been graphed here on an xy plane, where you take in any value of x and you output a value of y based on this equation here. And the solutions to this are where this curve cuts the x-axis here. So that's not very neat, but it's right here and right here. As you can see, it cuts this axis. You should already be familiar with factorizing somewhat, but in this video we'll cover it again for the sake of revision. And that means turning ax squared plus bx plus c into x plus number form. And if either of the brackets, such as this bracket or this bracket, if either of them equals 0, they multiply to the other one and turn it 0 as well, which turns the whole equation 0, and that's true. Let's factorize this expression right here just to show an example. First, let's take the values of a, b, and c. The value of a is the coefficient of x, as we know. X squared, I mean. And in this example, we can treat this to be a 1 there, because there's no coefficient. And here you might be tempted to think there's b is also 1, but you have to make sure, because there's a minus sign, it's actually minus 1. So let's write that down. A is 1, b is minus 1, and c, remember the minus sign should also be there, is minus 2. And what we can tell from how we've learned to expand these brackets, you have the FOIL method. First, outer ones, middle ones, last ones. You have to multiply all 4 of them. And that'll give you 4 terms which you can combine into an expression. And because of that, we know that this p and q multiply to the c term because they don't have any x. And p and q add to b because they both multiply to x. And using that rule, we can turn this into factorized form. So what two numbers add to -2 and multiply to -1? Yomesh, do you have any two numbers that add to -1 and multiply to -2?
I'm not sure, but can you tell me?
It should. So p times q should be -2, and p plus q should be -1. Now, there's no hard and fast method to this, but you just need to like think about it a bit. Um, just based off this, I can
Oh,
think
so would it just be -2 and 1?
exactly, because you have -2 times 1. Yes, that's there, and 1 time plus -2 gives you -1. So when you factorize this, you turn it into x minus 1, no, x plus 1, my bad, and x minus 2. When you open the brackets, you'll get that. So factorizing, I didn't cover it very well here because it's usually covered earlier in IGCSE level as well, but just as revision. And factorizing can get a bit more complicated than that. Like in some equations, they're not in standard form. Like you have something over here, and it's not equal to 0. And sometimes it can be simplified further, such as here. If you'll look closely at it, you'll see that everything can be divided by 2. So we would first divide everything by 2. Like divide by 2, 1 equals x squared plus 2x minus 68 divided by 2 is 34. And then since we want it equal to 0, we're going to bring that 1 over, subtract 1 from each side. It's 0 equals x squared plus 2x minus 35. And just from before, we need two numbers that multiply to 35 and add to plus 2. So I can think of -5 and 7 as these. It takes a bit of practice to get to this level where you can just think of them off the top of your head. See, because -5 times 7 is -35, and the difference between them is 2. So I will turn x squared. Nope, not the square. Oh crap, it's gone. X plus 5. Wait, no, it was x minus 5, x plus 7. Or, yeah, it is. So that's how we factorize it to this. But remember, we did divide both sides by 2, so sometimes some questions will require you to keep that 2 in there in later steps. And sometimes the factorization will have, like, the value of a won't be 1, so you have a coefficient for x squared. And that does get a little bit more tedious to work with when you're factorizing. It's the same method. First you get value of a, which is 3, value of b, which is 19, value of c, which is 6. And you need to multiply a and c. This is important. A times c, that's 3 times 6, which is 18. So now with 18, I'm going to split 18 into two factors of 18, which need to add to b. So what two numbers multiply to 18 and add to 19? This is actually a pretty simple one, because if you multiply 18 times 1, you get 18, and 18 plus 1 is 19. So that's pretty simple for us. So what we're going to do is we're going to take this, right, and 3x squared plus, and we're going to split it into 18x and 1x. See, the value is still the same. It's just slightly longer. And in this form, we can do something funny. We can factorize this part out. See, both of these, you take the highest common factor. The highest common factor is 3x. See, both of these can be divided by 3x, this one and this one. So we take out 3x, pull out the common factor, and you're left with x plus 6. And if you look here, you have x plus 6 here as well. Sometimes there will be a coefficient here, but right now there's not, so I'm just going to put 1. And as you can see, these two brackets are the same. So you take this number and this number, put 3x plus 1, you combine them, and you put x plus 6, the same bracket. And this is basically your factorized quadratic equation. And now if you want the values of x which give you 0, all you have to do is just find the value of x which makes one of the brackets 0. So in this bracket, x plus 6 equals 0, so x is obviously minus 6. Here, it's 3x plus 1 should equal 0. So it's minus 1 equals 3x, and x is minus a third. That's pretty simple. And now we have a workout, which Vyomesh will help us with.
Okay, so looking at this question, I would automatically think to take the x minus 1 to the other side. So it's currently being divided. So when it goes to the other side, it would get multiplied. So it'd be 3x plus 2 multiplied by x minus 1 equals to 2. And so as it's not equal to 0, it's equal to 2. So I would want to expand the brackets to simplify it. So it'd be 3x squared. And now it's getting multiplied by 3x times minus 1. So it'll be minus 3x. Then it'll be 2 times x, which will be plus 2x. Then it'll be 2 times minus 1. So that's minus 2 equals to 2. And now in this case, what we can do is that simplify, first of all. It'll be 3x squared minus x and what we can also do is that we could take the 2 on the right and then take it to the left, so it'll be minus 4 equals to 0. Great. So now we have a quadratic that we can actually solve for. So the method, everyone has their own methods that they can use, but there's also a secondary method that people can use, is to look at the factors of 4. What factors do you get? You get 1 times 4, and you get 2 times 2, right? Yeah. So we could take one of them to try out if it really works. With 1 times 4, for example, right? Remember the coefficient a, right? It's 3 in this case. So that will also get multiplied by one of the terms, 1 or 4. And then somehow we have to make it equal to minus 1, which is the middle term, right? So I can imagine it like this, that if I multiply 4 by negative 1, let's say, 1 times negative 4, and then I do 3 times 1, then that would be equal to minus 1. So, as I know, 3, right? It cannot be, it doesn't have any factors on its own. It only has 3 and 1. And so I could have 2 brackets, which has 3x, and then the other has x. Yeah. And now I just need to find the coefficients to put inside them. So on the right one, for example, I would put minus 1. Or wait, sorry, plus 1 in this case, yeah. Plus 1. And on the left, I could put minus 4. So what's exactly happening is that if I try to, expand the brackets, I'll reach to the exact same quadratic that we started with. And this is also a way that you could cross-check yourself to make sure that you're doing it correctly. Yeah. And
That's a great point. If
yeah.
you've arrived at a factorized place and you want to check if you haven't made any mistakes, you can expand that again to make sure that it checks back into the same equation.
Yeah, great. And so now what we would do is that we need one of the brackets to be 0, right? We could try it with either of them. So we could create an equation 3x minus 4 equals to 0. In which case 3x would be equal to 4, and x would be 4 upon 3. And with the second equation, we have x plus 1 equal to 0, in which case it's going to be simple as just taking the 1 over the other side, which would be minus 1. Yeah.
So our 2 answers, which is important. Some questions might have 2 answers, 1 answer, some might have none. We'll cover that in a moment. But here we have two answers for x, which are 4 over 3 and x equals -1. Pay
Also,
attention because there's
very
multiple marks.
important note will be to also put the values of x in the actual question back again to see if it actually works. Because a lot of times looking at the working out, you might actually make a mistake. So you have to be careful of that.
You can plug these values back into, substitute them into x, and make sure that this equation still holds.
Yeah.
That's a really good tip, Vyomesh. Thank you.
Thanks.
Now we're moving on to one of the most important topics in this chapter, which is completing the square. This is a powerful form which can give you the maximum value, the vertex of a square. So let's just draw these out. If we have a quadratic curve, that's horrible. I'll do it again. If you have a quadratic curve like that, the vertex is the point where it turns, like it flips. And it's also called the minimum or maximum point, depending on the curve. This is like a smiley face. So it's a minimum. Like this is the lowest the curve goes. That's the minimum. That's the vertex. And we can get that from a completed square form. And to complete the square, there's one simple method which comes out of this idea that expanding x plus n to the power square to the power 2, it has to be a square, expands to this with twice the values of both multiplied in the middle. And I'll just put solve a question because that's the easiest way to explain it. Here we have x squared plus 10x minus 3, and it's asking us to put it into complete square form and hence solve the question. This actually works for some questions which you can't even factorize, so it's pretty powerful. So the way we do this is we look at x squared plus 10x minus 3, and we just look at the parts with x in it, which in this case is x squared and 10x. We're gonna half the part which has x, half the coefficient of x, which is 10. So half of 10 is 5. 5. We're not gonna put x. We're gonna put x plus 5. And what this does holds x plus 5 whole squared. And what this does basically is, remember, if we have x plus 5 whole square and we expand it, then I'm gonna get x squared plus 5x plus 5x plus 25. And we can simplify this to x squared plus 10x plus 25. And see, now we've put this into completed square form, where instead of 5x, we've turned this 10x into this. And by turning this into x plus 5 squared, we've also introduced this 25, which we'll have to subtract away as minus 5 squared. And this always holds true. If you're doing like ax squared plus bx plus c, you're completing that. You're gonna first, let's say a is 1, just for simplification. Take x, and then half of b plus half of b whole squared, and then minus half of b squared. This plus c. This is the completed square form, what we're going to achieve here now. And remember, let's continue with this. This minus 3 still exists, equals 0. It's not the clearest explanation, but it'll do. X plus 5 whole square minus 25 minus 3 equals 0. And that gives us a final answer of x plus 5 whole square minus 28 equals 0. See, it's in the completed square form now. And it's in the completed square because we have a bracket whole square in it. That's what it means. And it says hence solve. So the way we can do this is take the 28 to the other side. So we're left with, I'm going to clear the board real quick. So just keep this in mind. X plus 5 whole square minus 28 equals 0. We had that. And we're going to bring the 28 to the other side. So we have x plus 5 square equals 28. And to get rid of this quadratic, the square, we're going to square root the side. And when you're square rooting, this is very important. When you're square rooting, you have to make sure the plus minus is there. Because there's two possible answers, remember, on the graph. There's two possible points where it crosses, usually. So when I remove this square and square root this, x plus 5 plus minus 28. And we got to get the x on its own. So we subtract 5 from both sides to get 5 plus minus square root 28. Now this does look kind of weird. We call it surd form. It's like some questions will ask you to give an exact answer. And this is what they mean. They mean instead of decimaling out the square root, they just want you to write the square root there. So that's our solution to this question. It gives both answers because there's plus minus, both values of x. And now let's talk about the vertex a little bit more. Remember, the vertex is this point here, or if the graph is upside down, this point here. This is a minimum, this is a maximum. And in completed square form, that, let's say, ax plus p squared plus q. This p there's a nice way to explain this. If let's say the x value here is p minus p. Let's say the x value here is minus p. And when you substitute in x as minus p, then it becomes minus p plus p. And this part just cancels out. So the whole square cancels out. And you're left with just q. And that is the highest possible or lowest possible value for the quadratic curve. So let's just solve a question with it to illustrate the point. Find the coordinates of the vertex in this curve and state whether it's a maximum or minimum. Remember, as before, we're going to complete the square. But here we have an a term. So what we need to do is we need to temporarily remove the a term. We can do this by factorizing it, putting it outside the brackets. X squared plus, what's 50? 10. X equals 7. And we're going to complete the square again. It's a very simple idea, deceptively simple actually. You just half the value of the b term, minus 5. Oh, that shouldn't be there. Half the value of the b term and square it. And remember, this 5 is still there. I'll just do that again because it wasn't very clear. 5 still there. You put it in a square, like completed square, whole square equation. Plus 5, half of 10 is 5. And you square it. And to get rid of that extra bit which tags on from that plus 5, which is 25, we subtract that 5 squared. And that's still equal to 7. Now we can clean this up a little bit. That's just 5x plus 5 whole square. And 5 times 25. Remember, this is minus 25. I'm going to use a calculator real quick. It should be like...
It's 125.
5. Yes. 125 equals 7. We subtract 7 from both sides. So now we have 5x plus 5 whole square. Remember, this 5 applies to the whole thing. And 125 132 equals 0. And if we draw this out, looks like that. Because right here, this is going to be minus p. So this is minus 5. Because when this x is minus 5 plus 5, this whole center section becomes 0. And when the center section is 0, then you're left with this being minus 132. You're left with this whole completed square bit. The square bit goes away and you're just left with the constant. So the coordinate vertex here is the minus 5 minus 132. That's going to be the coordinate of the vertex of this curve. And one quick and easy way to find the vertex is just minus b, like look here, let's see, minus 50 over 2 times a, which is 10. That gives you the minus 5, which is the value of x in the vertex. So it's just like a shortcut way of getting the vertex without completing the whole square. It is pretty important to complete the square in some situations later on, especially when you're in doing some more advanced stuff with quadratics. But for now, you can just use a shortcut method. But you do need to be able to complete the square, because some questions do specifically ask you to complete the square. And here's one thing, something you'll have already covered in earlier levels, the quadratic equation. All students love making fun of it because they don't usually use it in life, but you do. So here's the quadratic equation. And we're going to solve this quadratic equation using the quadratic equation. And Vyomesh, will you be willing to help us plug this in? Can you tell us the value of a, b, and c?
Sure. So considering the form, a equals to 3,
Goes to 3.
b equals to 1, and c equals to minus 5.
Minus 5.
Yeah,
And
and
now we're
now
going to
we
plug
just
these
put them
there.
Yeah.
Minus 1 plus minus. Remember plus minus, because you have to do this twice, because there's one answer for plus and one for minus. B squared, 1 squared, minus 4ac. Wait, I should probably write a and c out. A is 3, 4 times 3, times c is minus 5, over 2 times 3. And if you plug this into a calculator, then you get minus 1. It's important to know how to write in your calculator. I would show you, but it's hard to show the calculator screen. So usually you should use the fraction. It looks a little bit like this. You should use that button, and it'll create a nice fraction for you where you can type in stuff. It's very helpful. You should. A lot of students think that just having a calculator will allow them to do everything, but it won't. You need to know how to use the calculator. It's pretty important too. 2 times 3. Math error. Have I done something wrong with this equation?
I think it should be fine.
Let me just check. Oh yeah.
Yeah, it's
3,
correct. Yeah.
1 minus 5. So my calculator gives me these two answers. One is minus 1 plus 61 square root over 6. And the other, as you can guess, it's the same thing but minus. 1 minus 61 over 6. These are the two values of x.
Also, one thing to keep in mind, this is a kind of a trick some people would actually use a lot during your examinations. But when you've actually found the answer to these kind of questions, it's also sometimes helpful to check it on your calculator. There's one specific thing in calculators, especially if you have a calculator like this. If you go to the menu, and then if you go to the equation function solver, and if you try to solve for a polynomial, you could actually define the power of the polynomial, and then you would also be in a situation where you could substitute the values of a, b, and c, and you would be getting the roots of the equation. But to keep in mind is that you should always provide working out, because even if you get the answer sometimes, because this is going to directly give you the answer, it's important to also do the working out. Otherwise, you would lose marks.
Like I love using this trick. You go like on my
Yeah.
calculator, you go to mode. It's hard to see, but then it shows up one which has equation, and then you just select quadratic one, plug in A, B, and C, and boom, you get two answers or whichever answers. And as Vyomesh said, you need to be very careful because some questions are focused around the working on the quadratic. So just to be safe, always throw in the working and use this more like a checking tool. Okay, now we're gonna do some work on this stuff we just learned. Vyomesh, can you help us express this term in this completed square form?
Sure. So I would look at the -8 specifically in the value of the b, and I would half it. So it'd be x minus 4 square.
Yep.
And then I'm going to do minus 4 square, and then plus 11. Yeah. And so I'll just simplify that further by, let me just get my calculator. It's minus 64 plus 11. So that would be minus 53.
Yep.
Yeah.
And that's the form that it's asking for. You can see you have P and you have Q. Remember, P here is minus 4 because P is just that, and Q is minus 53. Sometimes my math teacher, he used to ask me to write out P and Q on the side. You don't have to, but it just looks nice if you have extra time or something. Okay, next part. Hence, find the exact solutions.
Okay, so I would most likely use a third form. The completed square form, because that's what question A was about. So x minus 4 square minus 53 equals to 1. And then just take the 1 to the left. Actually, no, wait, the other way around. Minus 53 to the right. So to get added. 54.
T4.
Yeah. And then I would square root from both sides. So x minus 4 equals to root 54.
Don't forget the plus minus. It's very important.
Oh, yeah, that too. It's very important to have that. And then just take the 4 to the other side. So it'll be 4 plus minus root 54.
So x equals 4 plus minus root 54.
Yeah.
And we've done exactly as it asked because it says hence. And since we've just done this form, hence means use that form to get this answer. Always pay attention to multi-part questions like this.
Also,
Thanks,
another
Vyomesh.
thing
Yeah.
to keep in mind is that look at question number 1b. It says find the exact solutions. So when they're talking about exact solutions, it's important to answer in the third form or any exact. You can't exactly just round up the numbers in this case. It's important to have that in a third form.
That's true. Like here, you can't just give a funny decimal answer like 11.34. No, you have to give exact, as in the square root, which is irrational, which so keeps going to. So to be exact, you have to use the square root in your answer.
Yeah.
Okay. Now we're gonna express 5y blah 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 in the form here. Same thing from before, except that we have a 5, and I've just chucked in hence find its minimum value for fun. So Vyomesh, would you like to guide us through this one again? This one too.
Sure. So I would first of all take 5 as a factor. So it'd be 5 brackets y square minus 6y plus 10.
Oh, you're gonna do the whole thing. Okay, that works.
Or actually, wait, it's also fine this way, yeah. Then we could just have plus 50 at the end, yeah. And then the inside the brackets, y squared minus 6y, right? So we're going to be we're going to do half of 6y, which would be minus 3y. Minus 3, and then square that. And then I'm going to subtract the 3 square,
Mm-hmm.
and then plus 50 outside of the brackets. And now after that, we have to just simplify it further on. So it'll be 5 brackets y minus 3 square. Then it's going to be minus 9 times 5. That's minus 45.
Yeah.
Plus 50.
And this we'll simplify that into
Yeah.
that's 50, my bad.
Yeah. So
Minus
it'll be plus
plus
5.
5.
Yeah, that's it.
Nice. So we've done exactly as the questions asked. And let's just, so that's your answer. It's 2 marks, so it's a pretty short question. And if it did like ask to find the minimum value, then important thing, if the coefficient a, let's say a coefficient a in x squared, if this is positive, then the graph is smiley. You can think of it as positive as smiley face, yay. And if it's negative, the graph curves like that. It's sad. And that will affect whether it's minimum or maximum. Here it's sad, it's happy. So it's a minimum, and the minimum occurs at plus 5, which is very convenient to find in our completed square form. So the minimum is 5. I think I'll just speed through this question, Vyomesh, on my own.
Sure. Yeah.
And this is kind of unconventional for a completed square form because we still have a coefficient of x in here. So I think this is more of like a trick question rather than a standard complete the square form question. So what we want to do here is treat this bracket as something to open. So as you know, that's an a, by the way, 4x plus a, that's what squared becomes. And once you expand everything, it's going to be 16x squared plus 2 times 4x times a plus a squared, which becomes 16x plus 8xa plus a squared. So what that's going to tell you is that center term will be multiplied by 8a and 10 here. So that just gives you the source of the 16. So to put that into this form, we're gonna first we have to put it into the completed square form. And to do that, we have to turn 24x, which as you can see in this form, it's minus 24x. Here it's like that. So minus 24x has to become is plus 8xa. So what do we know about a? Well, a is what multiplies this. So this is basically an equation. So a is actually minus 3. Because if we open up this bracket, then we get the center term, the term with x, and the only term with x here is 24. That these two are equivalent. So there's a plus. This 8xa is equal to minus 23. Hence, since a is minus 3, we put that there, close that, square that, and minus 3. It's still going to be 3 squared because 3 times 3, so 3 squared, to keep it balanced. And what's b going to be? We still have 10. So 4x minus 3, we found a. Now we need to find b, which is just simplifying. So minus 3 is 9, minus 9. Oh, one thing to do, pay attention. If minus 3 squared is written like this, the square only applies to the 3. But if it's bracket minus 3 squared, then it actually squares the whole thing and you get 9. Do pay attention when typing stuff like this into their calculator. It usually does this method first. So that's going to be minus 9 plus 10. So just plus 1. B is 1, A is minus 3. Nice. Let's carry on. This part is quadratic inequalities. The answers can look a little bit different to your average equation. There's one rule of inequalities that are different from equations, and then you should already know this. If you have like A is B, and you multiply both of them by minus 1, then that flips. The sign actually flips. Is because minus A is minus B. You can think of this like if you have 1 is less than 2, then -1 will actually be more than -2. Just a silly little rule that inequalities come with. So to solve a quadratic inequality, we first treat it as an equation and just get the solutions. You can use any method you like. You can use factorizing, or you can use completing the square, or you can use a quadratic equation. I like to use the quadratic equation, because it requires really less work compared to other stuff. You just type it in. And once you have the solutions, let's say you draw a rough graph and you plot, like, say, solutions here and here on a number line. And what that tells you is if the solution says less than, then it's going to shade this part. But if it says more than, you're going to shade the upper part. Let's just see a question about this then. Here we have x squared minus 3x minus 4. First step, treat it like an equation, find the answers. What are the solutions for x? I'm going to use the funny method, the cheat method, just as a shortcut. Minus 4. And what I'm going to see is that it's x minus 4, x minus 1. So the values of x are 0. We're going to start it as equality just for answers. So that gives us x equals 4 and x equals minus 1. With these answers, we're going to make a rough sketch. So we know that the coefficient of a here is 1. Positive. It's not 0, by the way. It's positive. So we know that it's going to be a smiley face. And the smiley face cuts the axis at 2 points, which are 4, is 4, and minus 1, minus 1. And what's the question asking? If you look carefully, you'll see that this part, which is the y value, the y value is greater than 0. And if y is greater than 0, that's actually these parts here. This keeps going up, this part. Everything under here, these values of x are the ones that we need. So the way we do that is, first, this is just a normal inequality sign, less than. So we're going to put x is less than minus 1, because on this side it's less than. And this side we're going to put x. Wait, hold up. Do not get your inequality signs confused, guys. X is. No, that's right. X is less than minus 1.
Was correct, yeah.
Yeah. And x is greater than 4. These are your two answers. Because on your funny number line, x is the part here and the part here, minus 1 and 4. See, we're gonna do another question about this later, but just make sure that the main parts are: make the sketch, treat your expression as y, and find the parts where y is. So if this was flipped, for instance, then we would, instead of having two answers like this, we would have x is greater than minus 1 and less than minus 4 if it was y equals less than 0. Then we'd have this part here. We'd have
Also,
the part under the
another
graph.
thing. Also, in our calculators, in most of the calculators, we also have an option to do inequalities too. Like how we said before, there's also a cheat method for the quadratics. There's also a cheat method for the inequality quadratics. But again, make sure that you're actually, doing the working out. And I've also found it kind of helpful. I've seen this tip somewhere. But just to be safe, do draw the graph and then show which region you're actually talking about. It first of all helps the examiner see if you're actually doing it the correct way or not. So that's one way you could it'll also help you think and visualize the question.
Thanks, Bromish. The drawing stuff in maths, it's actually super helpful. Later in the other pure chapters and even the statistics chapters, if you're drawing stuff, then it really helps visualize what's actually going on rather than just blindly following the numbers. So yeah, it's a good idea to draw stuff out. The next thing we're going to cover is the discriminant. And no, it's not discriminating anything. The only thing it's discriminating is whether it has two roots, one root, or no roots. The part under the square root right here in the quadratic equation is the discriminant. And what it tells you is how many roots there are to that quadratic equation. As you can see here, if it's greater than 0 or positive, then there's two roots. If it's equal to 0, then there's just one root. And if it's less than 0, then it never crosses the axis at all. It's no real roots. And one helpful thing to know is that when a line touches a curve at only one point, only one root, it's called a tangent. This topic comes up a lot in almost every question. So let's just do this, for example. How many solutions does this quadratic equation have? Again, we need the values of a, b, and c. B is -5, a is 1, and c is 12. So we put that as -5 whole square. Remember, the square extends to all of b. -4 times 1 times 12. And 25 minus 4 minus 4 times 12. This is actually less than 0. This is -23. The discriminant is -23. So what that tells us about this equation is that it'll have no real roots. You can confirm that for yourself. Yep, no real roots. If you try to put it into your funny cheat code thing, it'll give you I, which is imaginary, which means it's not a real root. Just keep that in mind. You don't need to cover complex numbers at this level at all. You don't need to worry about it. And we'll come back to discriminant, but first let's look at solving simultaneous equations. You've probably covered this in lower levels. Like if you have a line, let's just start with a line. If you have a line on the xy plane, right? You have a line, and there's another line. If you solve them simultaneously, you're looking at the point where the lines cross, where both of them are satisfied at the same time. Same idea extends here. If you have a curve and you have a line going through it, at which coordinates, basically, values of x and y, are both satisfied at the same time. Now, let's look at this example here. How do we solve it then? What I always remember is y equals y, y. It's a instant noodle brand over here. Anyway, you make y equal to y. What that means is, let's say x squared minus 3x minus 1. This is one of my values of y. And this is another value of y, 2x minus 7. And since they're both satisfied at the same time, that means their y, or the height they're at on the graph, is the same. So this stuff equals each other, basically. Y equals y. And now that we have this, we rearrange it into quadratic form. Nice and simple. Just bring the -2 over, -5. Add the 7 to get 6 equals 0. Solve for x, which is x minus 3, x minus 2 equals 0. And you get your values of x, which is 3, and x is 2. You might be thinking, oh, I've done this much, I'm done. but that would be wrong. Don't make this mistake, guys. It says the points on the graph. What that means is you need the coordinates x, y. Because if you think about this, if you just get the x value, it's like a whole range of unknowns all the way up here. You need the y value to make the point and tell you exactly where it is. So now we need to find the y values as well. It's pretty easy. You always want to put it into the equation where it's easier. Like this one, I can just plug in x equals 3, 3 times 2, y equals 3 times 2 minus 7, y equals 1 minus 1. Same here, y equals 2 times 2 minus 7, y equals minus 3. And it's very important that you match the correct x to the correct y. You don't want to mix them up. So for one of them, I had x equals 3, y equals minus 1. That's one of my answers. And the other point is x equals 2, y equals minus 3. These are my two answers. And now we can bring together these two ideas of simultaneous equations and the discriminant. And it'll tell you that after you combine them both into this y equals y equation, you can use the discriminant on it to see how many points that line crosses the curve. This is a popular style of question. The Cambridge examiners love this. They'll give you a curve and they'll give you a line, and they'll have one unknown, and ask for the set values of m where the curve is a tangent, or the value of m where it's a tangent, or the set values of m where it crosses at 2 points or doesn't cross at all. Let's just work on this real quick to show you what I mean. X squared minus 3x minus 1 equals mx minus 7. First thing first, we bring everything to one side. X squared minus 3x. And remember, mx it has an x, so the m comes with it. And plus 6, so that's plus 1. That's 1 equals 0. And if you get the value of b here, it might seem confusing at first, but you just the coefficient is actually minus 3 minus m, because you take out the x from both of them, factor out the x. So what you do then is you use the b squared minus 4ac, and that's equal to 0. That tells you tangent, it's crossing at 1 point, one repeated root. And you can put minus 3 minus m, boom, square that, minus 4 times 1 times c, 1, 0. And what you want to basically do is open this up, put it back together, and solve for m. So that'll give you the values of m. I don't really want to do it because it just take a little bit of time, but why not? Let's finish this. Minus 3, 9, and m times 3
Plus 6m
plus 6 m,
m,
and
then plus m squared.
Minus 4. That's it. So let's clear this. M squared, 6m, 5. M squared plus 6m plus 5 equals 0. Finish that off and you'll get, I'm going to use, there's actually two values m plus 5 and m plus 1 equals 0. So these are your two values of m that if you put these two values here, the line will be a tangent. And what that looks like on a graph is like maybe you'll have a curve and one line will be here, and if you flip it, the other line will be like here. So there's two possible values. That doesn't really illustrate the point, so let's get to our questions. Vyomesh will help us with this question here.
Sure. So let's see. The equation of the curve is given above, and where k is the constant. Find the set of values of k for which the wall of the curve lies on the x-axis. Oh, okay. The wall of the curve lies on the
So
x-axis.
the curve has to be above the x-axis. That's what it looks like, guys.
Oh, okay, okay. I do not see above.
Yeah.
Okay, lies above the x-axis. So what we're basically saying is that when it equals to 0, there are basically no solutions to that, right?
Hmm.
So we are saying that taking x squared minus 6x plus k, that would never equal to 0. And so we're going to be using the discriminant. So we're just going to enter the values and make it less than 0. So to
Yep.
be, in this case, b would be minus 6 square. Yeah. And then minus 4 times 1 times k.
Wait,
Should be less
this
than
should
0.
be less than 0.
Because we're saying that there are no solutions to it when it equals to 0. Because if it is touching the x-axis, that means that y equals to 0. But that's not going to happen. So we just simply simplify it further. Then it's going to be minus 4k less than minus 36. And then we divide both sides by negative 4. So it would be k more than 9. As you can see that the sign flipped due to it getting divided by a negative value.
Yep. Pay attention. Always be careful of that. So that's our answer. The set values of k are when k is greater than 9, then we'll have the curve above the x-axis. So it should be touching. Epic. And continuing from that question, find the value of k for which y plus 2x equals 7 is a tangent to that curve. Let's just copy down the curve on this slide as well. X squared plus minus 6k minus 6x plus k. That's our curve. And find the value of k for which that line is a tangent to that curve. And
Okay.
this basically is our expression for y. Oh, yeah, it is y equals. There you go. Oop, wrong way. Y equals this. And we have this also. Y equals 2x plus minus 2x, because we're going to flip it to the other side, 7. And I think I'll
So,
just solve this question, Vyomesh.
oh, okay, sure, that works.
And where are we? It's my drawing pad. Oh, there it is. So we have rearranged this so that it's y equals. And we can make y equal to y because they're intersecting. So x squared minus 6x plus k is equal to minus 2x plus 7. And now that we have this, we need to find out it's a tangent to the curve. So that, remember, tangent means discriminant, b squared minus 4ac is equal to 0. And what we're going to do here is bring everything to one side. X squared minus 6x plus 2x plus k minus 7 equal to 0. Simplify things. Minus 4x plus k plus minus 7 equal to 0. and then we'll get our b. Value of a is 1. Value of b, right here, -4. And value of c, so the terms without x, are actually k minus 7. And when you put that into our discriminant, b squared minus 4ac equal to 0, you'll get -4 squared minus 4 times 1 times k minus 7 equal to 0. And when we'll open that up, so it gets 16 minus 4k plus 28 equals 0. I'll get -4, and just do some arithmetic here. Bring that to the other side. 16 plus 28. 44. And divide everything by -4, and you get k equals 11. And it says find the value of k, so that tells us we're on the right track. There's only a single value of k. So you can confidently say k is 11. Okay. This question, a curve has equation blah blah blah. 5 marks. This is a monstrous question. Okay, Vyomesh, please help with this one.
Oh, okay, sure. So the curve has equation and a straight line has this equation. Find the set values of c for which the curve and the line intersect at two distinct points. So again, we're going to go with the previous strat, and what we're going to do is that we're going to form one quadratic equation, and due to its discriminant, we're going to make it more than 0. So as both have y in it, so we can make them equal x squared plus 2cx plus 4 equals to 4x plus c, because again, y equals to y. Simple as that. And then we take them into the same side. So it'll be x squared plus 2cx minus 4x plus 4 minus c equals to 0. Great. And then we could say that a equals to 1, b equals to 2c minus 4, and c equals to 4 minus c. And now when we take the discriminant, it should be more than 0. So it's going to be 2, yeah. So it'll be 2c minus 4 squared minus 4 times 1 times c, which is 4 minus c. Yeah, and that should be more than 0. So when we simplify it, we would get 4c squared minus 16c plus 16. And then it would be minus 16 plus 4c is more than 0. So now we're going to simplify it again. It's going to be, the final result would be 4c squared minus 12c should be more than 0. And now that's kind of easy. As said before, we're going to equate it. We're going to put the equal sign for right now, and then later we could see what to do with it. So we're going to write 4c squared minus 12c equals to 0. Here we could take c as common, so to be c brackets 4c minus 12 equals to 0. So in this case, we've got two brackets, either c equals to 0 or 4c minus 12 equals to 0. So we could go with 4c minus 12 equals to 0. Yeah, that's one of the solutions. And in the other solution, it would be 4c equals to 12 and c equals to 3. Yeah. And yeah, I think that's pretty much it. Find the set of values for C which the curve and line intersect at two distinct points. Yeah.
So
Oh wait, no. This is
inequality.
yeah, inequality again. Yeah.
Hmm.
So I completely forgot about that. So looking at the question that we started off with, it's 4c squared minus 12c. The coefficient of a is 4, so that's a positive value. So we know that's a smiley face.
Yay.
And in that case, if we're saying that it's more than 0, we're talking about the left and the right side of it, right?
Hmm.
And so for that, it'll be we can say that c is less than 0 or c is more than 3. Oh wait, the flip sign.
Wait,
Yeah,
C is
less than 0.
less than 0.
And c is more
C
than
is
3.
more than
Or
3.
yeah.
So these are our set of values of C,
Yeah,
where they displayed.
and as I did, I also read the question, like what they were asking one last time. So they said find the set of values. So then yeah, that was like triggering that. Oh, I found two distinct values, not a set of values. So that also helps.
Yep, the questions tend to be quite specifically worded in Cambridge. So if once you've done enough practice paper and you get like a sort of feeling after reading the question, like, did I do everything? And one thing Vyomesh did in this question, which is really important, is before solving the question itself, he came up with like a map strategy. First, I'm going to do this, and I'm going to get the discriminant, and then I'm going to get the answers. That's really important. If you can look at a question and come up with a strategy to solve it, then that's really good. Okay, last topic. Quadratic in some function of x. Some functions, we haven't done functions yet, but some expressions, they do sort of look like a quadratic. Like if you look at that, it has x to the power 4, x to the power 2, and that one has no powers. And you can make it quadratic so that you can solve it using the quadratic methods. What we're going to do here is we're going to make x squared equal to y, or any other letter of your choosing, so that when we put x cubed, and you'll know that from your exponent rules, that x squared whole squared, the exponents multiply and you get x to the power 4. So if you're not sure about that, please do catch up, but you should hopefully know this. So let's continue. Let's So now that we have a quadratic equation from that, we can solve for y. And you can use any method if you're choosing. I'm just going to use this method here, minus 5 plus 4. And I get y minus 4, y plus 1. Oh no, y minus 1 equals 0. And that gives me answers of y equals 1 and y equals 4. And you might think yourself done there, but no, you're not solving for y, you're solving for x. So how can we get x? So we already have this substitution from before. X squared equals y. To get x by itself, we're going to turn that into x equals root y. And it's remember plus minus because it's the square root. So now we can turn these values of y into values of x. And to do that, we can just x equals, let's do the first value of y, plus minus square root of 1. Hey ho, that's 1. 1. And another one for y, x equals square root plus minus 4. So x equals plus minus 2. So our answers to this equation here are x equals plus minus 1 and x equals plus minus 2. So that's actually 4 answers. And that will be, if you draw out the graph on Desmos, I suggest using Desmos. It's a really good calculator app, graphing calculator. If you have y equals 0, then it will actually cross the thing 4 times. See, 1, 2, 3. That's more than 4. it'll be like 1, 2, 3, 4, I think. It'll cross there 4 times. The graph will look something like that because it crosses the axis 4 times. There are 4 answers to this. Okay. Using that idea of turning an equation into turning a non-quadratic equation into a quadratic equation, then solving it, Vyomesh is going to help us solve this equation with the square root y in it for some reason. So how are we going to solve this, Vyomesh?
Sure. First of all, that denominator root y is not exactly looking good. So what I would do is that I would multiply root y on both sides completely. So we would get 6y plus 2
Plus 2
and then minus 7 root y equals to 0.
equals 0. And see,
And I could have...
looks nice now.
Yeah, it looks nice, right? So I could just take a random variable like x, for example, and make it equal to root y. X equals to root y.
Root y.
And so what is x squared? That's y, right? So we could replace the first term with 6x squared. And then let's say the minus 7 root y, right?
yeah.
That'll turn into minus 7x. And then we've got the plus 2, which we just keep it as it is, equal to 0. So now we've gotten a quadratic equation which we could just solve using factorization. So that would be that would be 3x minus 2 times that would be 2x minus 1.
Nice.
That works, right? Let's just check. Yeah, that does. Yeah. Great. And so after that, we just get solved for the values of x. One of the values of x is 2 upon 3, and the other is 1 upon 2. As said before, we're basically making each of these expressions equal to 0. So 3x minus 2 equals to 0, or 2x minus 1 equals to 0 to get these two values of x. Yeah. And now we look, again, it says we have to solve for y, not x. So we can write y in terms of x. Looking back at x equals to root y, we can square both sides. So it'll be x squared equals to y.
X squared equals to y.
Yeah. And so to find the values of y, we would just basically square the values we got. So y equals to 4 upon 9, or 2 upon 3 square, and 1 upon 2 square.
So y equals to 4 upon 9, and y is equal to 1 upon 4.
1 upon 4. Yeah, that's it.
Epic. And that's the right answer. Let's go. And this is another one of those. This looks kind of scary at first glance, but don't worry. It's basically the same thing as before. But instead of having a root y, we're going to treat this whole thing, we're going to treat this as a term, basically. If you have 2x minus 3, you can even put that in square, why not, is equal to y, then first thing, you can make it y minus 4 over y minus 3 equals 0. And that suddenly looks a lot more doable, doesn't it? Vyomesh, can you take it from here?
Sure, yeah. We could just multiply both sides by y. So we would get y squared minus 4y. Well, minus 4.
Just 4, because the y cancels.
Yeah, and then minus 3y equals to 0. After that, it just gets easy. You could just factorize, and that would be, let's see. Wait. That would give us y minus 4 and y plus 1. Yeah.
So and the y equals
two values
equals minus 1.
Minus 1 and 4.
Y equals 4. Nice.
And then looking back to the expression that we made for y, we can make that in terms of x. So if we root on both sides, so that would be 2x minus 3 equals to root y.
Root y plus
And
minus.
then so 2x, yeah, plus minus, sorry, my bad. 2x equals to root 3 plus minus root y.
Yep.
And then x equals to 3 plus minus root y upon 2.
3 plus minus root y over 2.
Yeah, and then we just basically
Epic.
substitute the values of y to get the values of x.
Yes. So I'm going to do that. 3. Whoa. Oh, and actually, if you look over here, y equals minus 1. You cannot root y equals minus 1 because it's negative. It's not real. So this, you can actually ignore this one. It won't give you real values. So you're only interested with this one. So x will equal 3 plus minus y is 4 over 2. So 3 plus 2 over. So your answer will be 5 over 2. Not x. Answers will be x equals 5 over 2 and x equals 1 over 2. That is because 4 becomes 2. Yeah.
Yeah.
And that will be it for this session today, guys. Thanks. I learned a lot. I hope you guys did too.
Yeah. And you can get hold of the notes on ZNotes website, and our social media handles are on display. So connect it with us. Feel free to drop in any questions you have, and see you in the later episode. Thank you.
Thanks, guys.